So inshallah, today I'm going to skim quickly the contents of this lecture, and if you have any questions, you can reach me on my office hours, and inshallah, I'm going to answer all of your questions. Today, we are going to talk about the content delivery network. What is exactly content delivery network? I refer immediately to one slide, which is the key slide here, this slide. That content delivery network is very simple concept. Instead, for example, I'm here in the United Arab Emirates and I want to surf an internet website which is located at America or located in America. And if I request for the website which is located in America, this is going to the data is going to travel very long distance between United Arab Emirates and America, and this is going to cost too much time, and the delay will be very high. Instead of this, we put something in between, which is the edge server. And the edge server is going to be the mediator between the origin server and the client, in which it is located too near to the origin server. For example, it can be, it's too near to the client, not to the origin server. For example, if the client here in the United Arab Emirates, edge server should be in the United Arab Emirates too. So, for example, if I ask for this website or this image, and this image is not available on the edge server is going to request it from the origin server and take a cache or copy of this file into it in the edge server, which is located in the United Arab Emirates. And then the copy will be going to the client and the response will be the file itself. So this is a request for the file and this is the response for the file. In the next request or sub request for the same file or the same website, no need to go to the origin server to take the website because we have cache here. We have a copy of the website here. So the second request will be easier because this edge server is going to respond immediately to the request from the client. So this is mainly what we are going to talk about all the day today. So this is very straightforward concept. It contains many concepts and I'm going to cover them all. But before going into the details about that, we understand what we are in. Because now I understand that all the lecture is going to talk about content delivery network, in which I take a copy of the data from the origin server to the edge servers around the globe, and the customer is asking for the request. If, for example, in the United Arab Emirates is want to be taken from the origin from the edge servers located in the same country, or too near to the country, or too near to the geographical location of the customer. And that's very important concept. If you understand it, that's it. And we are going to get into details about all the slides here. It's talking about we have lots of data, diverse data. For example, we have text, audio, image. We have large volumes of this kind of data, and we need a smooth delivery of the content to the user. And we need to reach to this concept, which is the data can be delivered at any location, at any time. Alaikum assalam, Abdullah. Yes, I'm recording. انا بسجل. انت عايز ايه؟
لا لان كنت خلاص ما نخلص بيت ان شاء الله.
عايز ايه بس؟
عن موضوع الكي كومبوننت. لا مو عن موضوع.
طيب.
فنخلص بيت ان شاء الله.
انا عامل اونلاين دلوقتي. اوكي. ماشي.
انت تخلص دكتور؟
انا اخلص على الساعه 8.
8؟
ايوه.
ان شاء الله بغير لانه
طيب ان شاء الله. Large volume of the smooth delivery of the content any location at any time is a critical issue for the success of the cloud services. Fast web content delivery is essential for producing high-performance computing in cloud and for better quality of service. Okay, so fast content delivery is essential for producing high-performance computing and better quality of service. Okay. we need to remove or reduce the load time or latency. Load time or latency is the time between the ask of a request and getting a response. For example, if I want to serve www.google.com, so I write www.google.com and then enter. And after putting enter, I wait for the load time. The length will be load time, or the time that will be passed starting from putting go until I get the response. This is load time or latency. If the load time is long, this is going to be exhausting for the user. Is going to be bored because he's going to wait long time. We don't want the user to wait long time, and that's the main objective of content delivery network. Why we have a problem? We have a problem because we have a distance, geographical distance. The servers are not located in the same place of the client, and we need to find a way to make it easy for the client to reach the content which is far away from him. Type. Okay, so we have a limited number of data centers, and these data centers are distributed around the world, and but we have limited amount of limited number of data centers, so we have to get good management to deliver this content. Okay, and now we talk about the problem. The problem is we have lots of data and we want to deliver this data to the customer in very short time. The solution, we have a delay, and the delay happens because we have number of hops, of router hops, that the data should be hopping all the way from the server to the client, from America to United Arab Emirates. They are going to pass by many routers in the way. These routers, we call them hops until it gets there. The more the hops, the more the delay. Latency also is going to be affected because latency means download time is going to be very high. And the bandwidth also will be affected because we have lots of requests for the same server, and this bandwidth is going to be affected. Sometimes the server will be down because we have lots of requests at the same time. The cloud solution is replicate the instance. So we talk about the problem, now we start to talk about the solution. The solution is to replicate instances, to have replicate instances different geographical location around the world. If we have them, we can easily distribute them according to the business. For example, I have customers in Saudi Arabia, and I have other customers in Kuwait. So I can put edge servers in Kuwait and put other edge servers in Saudi Arabia, and try to let the users use the corresponding for example, for customers in Saudi Arabia, they are going to use the edge servers in Saudi Arabia, and those who are in Kuwait, they're going to use the edge servers in Kuwait. They are replication of the same servers. For example, if the servers are located in United Arab Emirates, and the business is located in Saudi Arabia and Kuwait. So we have the servers or the origin servers in United Arab Emirates are going to be replicated many times in the edge servers around the Arab countries. So here the solution is to replicate, and this replication we call it content delivery network. And this is content delivery network. We talk about the concept. We said we have origin server, and this origin server is going to replicate data to many edge servers around the world, and the client will ask for a request, and the response will come from the nearest edge server geographically near to the customer. Okay, the same thing is the most important point here is point of presence, which is the same name as edge server and is located in the Etisalat and Do in our country. So point of presence means the edge servers, and the edge servers completely located in related to the communication company like Do and Etisalat. Before cloud, I know you will ask, is it new for the cloud, this edge server? And then no, this is content delivery network. It is started at the beginning of the internet. It started at the beginning of the internet. So we have internet, we have immediately of content delivery network, because basically we cannot have a very fast communication, or very fast we cannot have very fast communication without having the content, or very fast download and upload without having the content delivery network. Not all the content need to be replicated, because we have content types. We have static content, we have live media. The static content is talking about HTML pages, images, videos that are static to the website. Live media, we have the media that is going to be changed, and every one of them is dealt with different technique. Yeah, we have techniques for static content. We have other techniques for live media. Okay. I should wait for the اذان. هستنى الاذان وبعدين اكمل ان شاء الله. So we have different types of media. We have static media. Okay, let me see if I didn't stop sharing. Okay, so, and make sure that you can hear me. I think so. You can hear me. Okay, we have static media. We have live media. Live media, each one of them is dealt with different techniques for content delivery network. So static content, we're going to duplicate or make copies of the static contents. For live media, they have different type of, and it's more challenging because the live media means we have media that is going to change in every second. Okay, so we have a collection of policies in CDN. We have these 4 policies: placement of edge servers. This is going to be decided on for edge. We talk about what? We talk about cloud computing, and you take a cloud from the cloud service provider. You take a cloud, and then you want to provide edge servers in many locations. So you have to decide this yourself. The second part in the policy, content management policy, and we will talk about all of these content management policy in which we have content, and this content should be replicated according to whether it is static or dynamic or live media. And the content delivery policy, how to arrange this policy. For example, if a customer in Saudi Arabia is asking for the content, which edge server is going to reply, and so forth. Request routing policy also, the whenever, for example, we have a user in Saudi Arabia is asking for data, or in United Arab Emirates, the same thing. If he's asking for a media in an edge server located in Sharjah, and then he found this edge server very swamped with requests, maybe this routing policy will redirect this user to another edge server in Dubai. So this is request routing policy. The policy, so you can see we have content placement of edge servers. This is very easy, and we're going to talk about this content management policy in the next slide, and content delivery policy, the slide after the next slide, and the third slide we'll talk about request routing policy. So here we talk about content management policy. Here we talk about content delivery policy, and the last one is talking about request routing policy. Okay, so the upcoming 3 slides are talking about each one of B, C, and D. Okay, so content management policy. We talk about 2 types of policies for full site replication. We are going to, if the site is static or relatively static, so we're going to take a copy of the entire site from the origin server to the edge servers. If it is partial, so we'll talk about, we will see which part is static and which part is dynamic, and that the static will be replicated, the dynamic will be dealt with in different way. We'll talk about one of these ways in the last slide, inshallah. Content delivery policy, depending on the caching techniques, the most important thing is to have a consistency and integrity of the content. For example, we don't have duplication of content on the same edge server. Also, synchronization between edge servers is very important. So maybe a user is asking for request in Sharjah and another user is asking for the same request in Dubai. They have to take the same response, not to have different responses at the same time. So there should be a good synchronization between the edge servers. There are content updates policies. Content update policies, we have 3 policies here, triggered by the content change if the website is changed, or in-demand updates if the user want to update. Periodic updates is to update in every specific amount of time. For the request routing policy, we have also the decision of the request directed to closest edge server. This closest edge server is going to be decided upon the following parameters. The first parameter is the type of the requested resource. The second parameter is the location of the user. The third is present state of the network, and the last one is load state of the edge server. Type of the requested resource, if it is dynamic or static. Location of the user, where exactly is the user geographically. Present state of the network, if it is swamped with requests or have high traffic or low traffic. Load of the edge server, if many requests on the edge server, maybe we can redirect some users to another edge server if we have lots of requests for some specific edge server. The content delivery network model, we have the publisher subscriber model is going to be used here. The publisher is publishing the data to the origin, the content origin, and the content origin is transferring the data to the content delivery network, but with authorization from the publisher. After authorization, the subscribers can request for data and they get the corresponding response from the content delivery network. Advantage of content delivery network, accommodation to heavy traffic, because we can add more edge servers to accommodate more users, support more simultaneous users, they are the same. If we have many traffic, we can add more edge servers here. Also, we can have more than hundreds and thousands and even millions of users at the same time, because each group of users can be directed to specific edge server. Less load on servers, because we have the origin server is not loaded, the edge servers are loaded more. Faster content delivery, we don't have to wait too much time to get our request as user. Lower cost of delivery, because we will not consume too much bandwidth. We will not consume many requests, and we will have low data traveling on the internet. Okay, facilitates scalability, means we can add more horizontal scalability, we can add more edge servers, so we have more scalable or more large or larger data or larger network or infrastructure by adding more and more edge servers. And this is, we call it scalability. Better security, because we have lots of replication. So if one of the data servers are down, we can restore it from other edge servers. The disadvantage of CDN, we have new point of failure, because we are adding a new point of failure of the edge server is failed. This means it's a point of failure. Additional content management task, we have to do the management of content delivery, and this is a headache. So instead of having the user is directly asking for the content from the origin server, we have to do management of replication of data around the world using the edge servers, which are located geographically in many places. So can AWS help us to do Amazon or to do the content delivery network? Yes, we can do Amazon CloudFront and Azure Content Delivery Network. Amazon's CloudFront and Azure Content Delivery Network. The Amazon CloudFront is the one for AWS, and we have, of course, we have in the foundational. You can go to this lab and see how to do it, but it's not mandatory as we finished all the labs. Azure Content Delivery Network is one other service provider. Now we talk about caching. We finished the content delivery network, and we talk about caching. Caching is part of the content delivery. Caching means a copy of the origin server to the content or the edge server. We store subset of data. Okay, I give you an example of cache. Okay, suppose I'm having 1 million dirhams. Suppose I have 1 million dirhams at the bank, or I hope so. I dream of so. And I cannot carry all the 1 million dirhams in the bank. I cannot carry them in my hands or my pockets or even my bag. This is a very huge amount of money, and they are going to make me worry every time I go to any place. And instead, I take cash, and this cash makes me light, and also I can buy and sell. For example, if I'm renting cars or buying and selling cars, so I can buy and sell cars and make deals using this cash. So I have two situations. Either my cash is increased because I gained more money, so I go back to the bank and put the extra money to the bank. Or my money is finished because I have more and more expenses, so I have to go back to the bank and withdraw some other money. So this is exactly the same scenario which is happening inside the cache in anything, even the cache memory in your phone or the cache memory on the computer. They are talking about the same concept. The same concept applies for the cache. Here, instead of going to the origin server, which is located in America, I can take a copy of the Google website from here, from an edge server here in the United Arab Emirates. This copy, we call it cache because it's going to be cached on the edge server. By the way, the cache also is found on your PC. So some of the content of your websites are cached in your PC. So if this cache is okay, so it's going to be useful and you are going to use it. If it is not okay, they have to go to the Edge server to take a copy. If the Edge server doesn't have the up-to-date content, they are going to take it from the origin server. Okay. Okay, so this is an example of the cache. As I told you, if you want to buy something, this is your house and this is the hardware store. You cannot go directly to the hardware store to buy something. Instead, you go to the nearest supermarket, or the nearest mall to get your things from there. You don't have to travel far away to the hardware store to get your things. You can get to, for example, if you want to buy a banana, for example, you cannot go to the farm very far away from your house to get a banana. Instead, the retail points, they provide you with bananas, and you can, from your house, the nearest point or the nearest shop, you can go to the nearest shop and buy bananas from there. You don't have to go to the farm, the bananas farm, and take bananas from there. You can get to the nearest point which is selling the bananas. Okay, this is the same concept here for the cache. Okay, you can read this. This is very trivial, and this is also is talking about the benefits of caching. Here is very important part. Here you see we have here the desktop and mobile application users. They are dealing with the internet edges. They're connected to the internet, the edges here, the edge servers. So they are dealing immediately to the edge servers, and they don't see the back end here. They don't see anything here because we have database, and database connected to the application server, and this application server is taking data from the database and distribute it among the internet edges. And whenever this user asks for something, he don't know even the application server, he don't know even about the database, he knows only the internet edge. For example, if I ask for a website, Google website is going to be retrieved from here in United Arab Emirates, and database in America, and application server in America. So I'm dealing with the edge server located in the United Arab Emirates, and that's fine. And I'm dealing always like this. So if this guy is periodically update with database servers and application server, periodically every, for example, 2 minutes, he's taking care that he's making sure that there is no update. If he encountered an update, he's going to take a copy from the application server and database to the edge server, and the user is going to he's going not to feel anything changed. He always deal with the edge server, as this is the only place the user is dealing with. If you want to take the travel or the data, originally is going to travel from the origin server to the user, and this is going to make a hops until it comes to go in there. So edge caching is going to be connected to the nearest router, and the user is going to deal with it. Amazon CloudFront is one of the services provided by AWS to provide the content delivery network, and it is built as a multi-tier cache and it adds an extra layer of security. It can deal with WebSockets, HTTP and HTTPS. So if whenever you have application, if you have web-based application or normal website or secure website, all of this is available in Amazon CloudFront. This is an example of websites, and here we have some of the contents can be cached and some other cannot be cached. For example, this image can be cached. This video can be cached. This web objects can be cached. Web objects talking about the structure of the entire page. As you know, this design is not going to be changed every second, for example, or even every day. So web objects are cached, so the structure of the website is cached, and no need to every time to retrieve the web objects from the website. Here is an example of the security layer added by the Amazon CloudFront. Here we add AWS WAF, or Web Application Firewall, to deter the DDoS attack. The DDoS attack is stopped by adding a layer of AWS WAF. And here is example of having the map tiles. If you, for example, if you have an application of map tiles, you don't have to download the entire map. You will download only the part that you have and the cache of it, not on the entire part. So here we have the CloudFront is near to the user, and this CloudFront is taking data from the Elastic Load Balancing to distribute the requests between all these instances, and is going to cache the data here is going to be cached for the edge servers in the CloudFront, and then the user is going to take the cache from the Amazon CloudFront. This is one example of video on demand streaming, and this is also supported by Amazon Web Services or CloudFront specifically. We have the user, and this user is using his mobile to watch live football game. For example, if this football game here in America, and this is going to use AWS Elemental Media Convert, this is going to convert this video into multiple sources at multiple fingers, and each finger of these fingers is going to be distributed on some of the nearest Amazon S3 Amazon CloudFront storage, and then it's going to be immediately going to, and instead of having only one source, we can distribute the same source into multiple instances, and the users is going to deal with these instances immediately. And that's it for today. Thank you very much, and I'm looking forward to seeing, so inshallah, in the practical exam. The practical exam is covering mostly the labs. I sent you an email, and you need to cover all the labs. You study all the labs, because most of